class, we will be looking at reflection in the line y equals mx plus b, reflection of a line, and a line. So in the last video, we looked at the same topic, which was reflection in the line y equals mx plus b, but in that video, we reflected a point about a line. But in this video, we will be reflecting a line about a line. So for a little summary, the line y equals mx plus b looks like this. So y equals mx plus b never crosses the origin like this. This is y equals mx, as you can see. But if it looks something like this or like this, then that line is y equals mx plus b. So that's all you need to know on what this kind of line looks like, so you can be ready for this kind of question. So when we're reflecting a line in a line, there are three cases that we need to look at. So the first one is when the lines are perpendicular, or when S is perpendicular to L. So to define some very quick references, S is the line reflected, and L is the line of reflection. So never forget these 2 points. So when we look at this, if the two lines are perpendicular, that we know that the slope is, if m1 equals, for example, h, then m2 is gonna equal to 1 over h. So what this means is that the slope of S is the negative reciprocal of L, and vice versa. In this case, the image of L is itself. So the image of S is itself. And the next case is when S and L are parallel, like this. So when they're parallel, we know that their slope is the same. So m1 is gonna be equal to m. So if they are parallel, their slope are the same. So when we reflect it, it's gonna look something like this. So if our xy plane looks like this is L, this is S prime, and this is S. So S prime is the line that was reflected. So to find the equation of S prime, then we need to first we choose a random point from S. Let's say this is 1, 2. And when we reflect it, it gives us the point 3, 4. So when we reflect it, we use the same slope as L or even S, because all of these three lines are parallel. So the line 1, 2 is A, then A prime will be 3, 4. So we use the same process as we saw in the last video, and then we will basically calculate the equation of this line. So since they have the same slope, let's say the slope is m equals 4. So to find that, we use the formula y minus y naught equals m x minus x naught. In this case, y naught is gonna be 1, 2, so 2 equals the slope is 4x minus 1. So y minus 2 is equal to 4x minus 4. And when we calculate this, this is gonna give us 4x minus 2. So this is the equation of our line. Most of these two cases are pretty theory based, but you can do practice problems on your own since they're very simple. The third and final case is when they are neither perpendicular and nor parallel. So their graph is gonna look something like this. Yeah, so this is how the lines will look like on the xy plane coordinate system. So let's label each so we have a better idea what we're working with. So let us start. So as you can see here, this blue line is the line of reflection. This is S and this is S prime. Okay, so this is easier to label this way. So, and this point here, the point of intersection is C. Okay, this is really important for later. So let's work through this in an example, okay? So we are given the line of reflection and also the line that we're reflecting. So we are given the line of reflection as y equals x plus 3. I mean x plus 4, and s is equal to minus 3x plus y equals to 2. So this is what we're given. This is what we're dealing with. So the first thing we need to do is to find the point C. So why do we find the point C? I will explain later. So first, let's rearrange this as y equals 3x plus 2. Okay? So once we have rearranged this, we will be proceeding to find C. So when we find C, if you have a notebook, please follow along by taking some notes on the steps. So this is the first step. We need to find the point C. So first we need to put them in the system of linear equation and then solve. As you can see here, but they're both equal to y, so x plus 4 equals 3x plus 2. And here we will find for x equals 7, no, not 7, 2. Therefore, x will equal to 1, I believe. There has been some kind of miscalculation. So 3x minus x is equal to 2x, and 4 minus 2 is 2, so x equals to 1. Did I say this before? I don't know. Yep, we're correct. So, and then y, we're gonna plug in 2 in one of these, and then we will get 5. So this is our answer. So C is equal to 1 comma 5. Once we find C, then we need to find a random point on the line S. So S is, as you can see, y equals to 3x plus 2, right? So we can just take the y-intercept, which is 2. So a random point will be 0, 2. So here we will have 0, 2. So after we find 2 random points, we will proceed to find, then we need to find the reflection of this. So let's call this A. So as we saw in the last video, we reflected a point, right? So we're gonna do the same thing here. So we're gonna draw a broken line from here to here, which is our reflected point. So as you can see, this particular line, let's call it D, line D, and then this is perpendicular to the line of reflection. So once we have this setup, then we need to know that the slope of our S prime is gonna be, line D is gonna be the negative reciprocal of the line of reflection. So why do we do that? Is because we need to find the equation of the line of this in order to find A prime. So D is equal to, so M, which equals to the slope of line of reflection is 1, so the slope of D is going to be -1.